So the second type of conic sections that we're going to talk about are ellipses. And when you're making ellipses using a geometric definition, then what we find is that the distance from one focus to any point on the ellipse plus the distance from that point to the other focus, the sum of these two distances stays constant no matter where you are on the ellipse. So if I pick a different point and I do the distance from one focus to that point and the other focus to that point, and I add those two together, I'm going to get exactly the same number I got as when I added the blue strings together. So that's the geometric definition of an ellipse, is the set of all points such that the distance from that point to each of the focus points added together is a constant number. So this is an ellipse with the major axis or the longer axis along the x-axis. So it's bigger horizontally. So the bigger number will be under the x squared term in the equation. So we have squared terms for both x and y and a plus, and that's how you're going to recognize or identify the ellipse. Then the lowercase c is the distance from the focus to the center. So see how there's all these c's, the distance from the focus to the center. So c is always that distance from the focus to the center or the center to the focus, whichever way you want to think about it. So in this picture, you can see it here. And that c, if you square it, is the difference of the denominators. And this can be proved using geometry, the Pythagorean theorem, but we're not going to take time to do that. We're going to work on learning about the ellipses. But this difference of the denominators is important. It doesn't matter which one's bigger. Do the difference in the way that gives you a positive number, because c squared has to be a positive number. So when the ellipse is larger in the y direction, then it will be the y's denominator first. So for the rest of the section, when the directions say analyze the equation, it means find the center, the major axis, the foci, and vertices of the ellipse. So the parabola has one vertex and one focus point. Ellipses have two foci and two vertices. The vertices are the farthest away points from the center. So I find it easiest to draw the graph to get all that information. So we're first looking at ellipses that are centered at the origin. And I look under the x squared term and I see 9. Well, I know in that basic equation that number under the x squared term is squared. So I know that a is plus or minus 3, and that's the distance from the center in the x direction to a point on the ellipse. So I start at the center is at the origin, and then I go 1, 2, 3 in the x direction, 1, 2, 3 in the opposite direction, labeling my axes. And I see that the denominator under the x term is larger, so I know these are vertices. Only the farthest away points are given the name vertices. So then I can look at the number under the y squared term, and I see that's the number 2 squared. So that tells me how far I go in the y direction from the center to get to 2 more points that are on the ellipse. So the center is the origin for these first few problems, so got that. The major axis goes through the vertices and the center. So in this case, the major axis is the line y equals 0, or the x-axis. Then let's come back to the foci, because we can see the vertices from our picture, 3, 0, and negative 3, 0. So now the only thing we need to worry about is the foci. So I'd encourage you, if you are going to use one-letter abbreviations, to make sure your C for the center looks somehow different than the lowercase c that's talking about the distance from the center to the focus. So let's look at c squared, which has to be the difference of the denominators. So c squared is going to be 5. So that means c is going to be plus or minus the square root of 5. And that's my distance from the center to the focus. Square root of 5 is a little more than 2. It's not important exactly where we put it. You can label it as square root of 5, so you remember that's how far out it is. And this is a focus, and this is a focus. So now we can look at the graph and see that the foci are at plus or minus square root of 5, 0. And then graph the ellipse. So that's the easiest part once we have all these dots in place. And make the ellipse as symmetric as you can. It should be symmetric if it's folded across its major axis or folded across its minor axis. Okay, now let's look at a question that's kind of a puzzle of, let's see if we can put all this information together. And I'm a big fan of drawing pictures. So I'm going to put the center at 0, 0. And then I'm being told that there's a focus at -1, 0. So I know there's another focus in the symmetric spot. There's mirror image everywhere in the ellipse. So then I know that there is a vertex at 3, 0. So there must be another vertex at -3, 0. So that's a vertex and a vertex. So we know that the ellipse is longer in the x direction because the vertices are always the farthest away points from the center. So far I know I have x squared and y squared and a plus, and that has to equal 1. In the x direction from the center to the vertex is 3. So 3 squared goes under x squared. Then I don't know what goes under the y squared. So let's see if we can figure it out from what we know. We know c squared is going to be the difference in the denominators. Well, we also know that c is the distance from center to focus. So that's a distance of 1, and 1 squared is 1. So we can see that b squared is going to have to be 8. Well, we don't really care what b is because we were just asked to find an equation. But then when we go to do the graph part, then we will need to figure out about how large b is. So now let's write our equation of the ellipse, x squared over 9 plus y squared over 8 equals 1. So that's find the equation. Then in the y direction, I go plus or minus square root of 8. Well, that must be a little less than 3, because square root of 9 would be 3. And it's not super important exactly where you put that, as long as you know that that's square root of 8. So then we can draw our ellipse. And now we've graphed the equation. Okay, an ellipse can be longer in the vertical direction, and the only thing that really changes is when you look at the denominators. The denominator under the y squared term will be larger than the one under the x squared term. But all the relationships stay the same as far as the vertex being the farthest point from the center. And the lowercase c squared is still the difference of the denominators. You just have to make sure and subtract the smaller one from the larger one. And the distance from the center to the focus is that lowercase c. So let's look at an example here where the equation's not in standard form. We know we have to have the 1 on the left. So we create that by divide both sides by 36. So then I'm going to have y squared over 9 plus x squared over 4 equals 1. So now I can see how to draw my ellipse. The center is at the origin. Then under the y squared term, I see 9. Its square root is 3. So in the y direction, I go up 3, down 3. And those are going to be the vertices because it's bigger in the y direction. And then under the x squared term, I see 4, and I know that's a squared number 2. So in the x direction, I go positive 2 and negative 2. So I can make my graph. And different people find it easier to do this different ways. Some people do one quadrant at a time. Some do one big loop. It's however it works best for you. So let's answer the questions here. We know the vertices. We can see that it's 0, 3, 0, negative 3. Now to find the foci, we're going to need that little c squared, and that's going to be the difference of the denominators. So little c squared is going to be 5. So that means c is plus or minus root 5. So that's how far I need to go away from the center. And root 5 is a little more than 2. So I can put a dot here and say that's at root 5 in case you can't tell by looking at it, which I can't. So that helps us find the focus points. So we're going to be at 0, comma, plus or minus root 5. Okay, then here's another one of these puzzle problems that I find it really helpful to draw. Here's the center at 0, 0, focus at 0, 1, so I know there has to be a mirror image focus at 0, negative 1. Then I have a vertex at 0, negative 2, so I know it must have a twin vertex at 0, 2. So because of the symmetry of the ellipse. So now we see what I think of as the shish kebab of vertex, focus, center, focus, vertex along the major axis, which is the y-axis. Okay, so it's larger in the y direction. And from center to vertex, it's 2. So we square that and put it under the y squared term. Then we don't know what number goes under the x squared term, but we do know something about little c. Little c is the distance from the center to the focus, so that's 1. So c squared is 1. So the difference in the denominators has to be 1. And we know the denominator under the y term is larger. So that tells us a squared is 3. So now we know our equation looks like x squared over 3 plus y squared over 4 equals 1. So there's our equation. And then in the x direction, we need to go a equals plus or minus square root of 3, which is a little more than 2. Little less than 2. What was I thinking? Little less than 2. And then draw your ellipse. Okay, so I'm going to pause here, and then we're going to allow the center to go somewhere else besides 0, 0.